Hi students, it's Dr. Marks, and today we're going to talk about information literacy as it might apply to our ECON 301 class. Now you're probably aware that ECON 301 is a perspectives course in Civitate, and as such we are required to cover the topic of information literacy, and we will be applying it during this class. We're going to start by talking about data and information. So you can imagine that economics and also sustainability and things related to the environment and science are going to be fields that rely heavily on information. And of course, one key type of information that we use is data. And as an economist, we use data all the time. So in my classes, we talk about things like economic indicators, GDP, inflation, things that you're probably a little bit familiar with because you hear about it in the news. Environmentalists in the same spirit are going to use data to talk about things like species diversity, or maybe they're looking at measures of environmental protection. Have certain new regulations been effective? Well, data would be an important way to confirm that. It would be hard for us to show Costa Rica's success as a leader in environmental protection and sustainability. And it would be hard to show its success with sustainable energy, which they're on the frontier, without relying on data, right? If we look at the data, it's very easy to say, look, they're a leader in this field, even though they're not a very wealthy country. They are doing amazing things, and they're on the frontier of sustainability. Why should we use data? Data helps us illustrate. So economists and scientists both rely on data for illustrations. And sometimes that's going to be a single statistic. Maybe in my economics class, I'm talking about GDP, gross domestic product, a measure of, let's think about it as kind of output for the nation in 2020. Or I might be thinking about how much energy was consumed per person in 2022, right? Everyone agreed that those are single statistics. They're just for a snapshot in time. But we use lots of data for developing charts and graphs. Charts and graphs allow us to look at trends. Are things going up? Are things going down? Do we see instability? Does there seem to be a lot of noise? For example, I might graph inflation over time, and as I record this, we're sitting at one of the highest inflation rates we've seen in a very long time, and so a graph would be a really nice way to depict that. I can kind of show normal inflation rates, and then boom, all of a sudden as I'm recording this, we're sitting at something like 8.4% inflation, and a graph would make that very clear. I could be looking at tracking use of hydroelectric power over time. So if I looked at Costa Rica's use of hydroelectric power over a long period of time, that chart is going to show a very clear increase. I could make a figure, a graph out of it, and it's going to be very transparent and easy to see the trend. Data helps us educate and inform people. You're going to learn a lot of new information in this class, and much of it will be tied to data that informs you about things. For example, Costa Rica's economy. We need to take a look at their economy and get a sense of what does their economy look like? What's their success in green energy? We already know that they're a leader, but what does that mean exactly? Well, we can use data to help us paint that picture and inform us. We can also use data to motivate or justify a point of view. Now, if I wanted to say that the quality of the environment is improving, data would be a good way to justify that. Or if I wanted to say there's been greater protection of rainforests in Costa Rica, same kind of thing. We need data to be able to motivate or justify our point of view. If I'm going to make a claim like that, backing it up with data is obviously a very good thing to do. Data also moves us out of the normative, and this is important for you to understand. And in my principles classes, I make sure students understand the idea of normative and the opposite, which is positive. When we talk about things that are normative statements are our opinions, and we're not always being asked for our opinions. So we have to decide, does it make sense to be in the normative? Well, normative statements are ideas that cannot be tested. So I can't apply the scientific method to answer the question. I can't confirm it with data. I can't see if it's true or false in that manner. So as I said, it's going to involve an opinion or some kind of value judgment that makes it harder to evaluate. So let's look at some examples of normative statements. Costa Rica should be more concerned about the use of gasoline given the growing number of cars. All right, well, there's probably going to be a lot of people who would agree with that statement. Costa Rica should be more concerned about the use of gasoline given the growing number of cars. But there may be people that don't agree with that statement because they think there are other priorities. There's one word in that statement that jumps out as being highly normative. So what word would that be? Read that sentence one more time. What word really signals this is normative? The word should, right? When I say somebody should do something, or I should do this, or a country should do that, clearly that is going to be opinion. What if I said Costa Rica's priorities are appropriately set? Again, I might be able to back that up with some data to make it less normative, but as written, as stated, this is just kind of my opinion, and I can't test it. I can't evaluate if it's really true. I can use data to try to confirm it and back it up, but as written, this is just an opinion statement. Generally, we want to be speaking in the positive. Now, not all the time. Sometimes you're asked for an opinion. But in economics, generally, we're thinking about things in the positive. In other words, we want conclusions that come from theory or models or data. Because if we have conclusions that come from economic theory or economic models that we use in our classes or from data, well, then these things become testable, right? And when they're testable, then they don't reflect our opinions and they're not imposing a value judgment. Unless the assignment specifies to give your opinion, which of course would be in the normative, then you might not want to do that. For example, maybe you're asked to write a paper on your opinion about the Endangered Species Act. Well, if that's what you're asked to do, and your professor clearly frames it as that, then this clearly needs to be normative, right? You're talking about your opinion, your values. Maybe you don't think it's worth it. Maybe you think it's too much of a waste of money. You don't think it's an effective policy, that our efforts are better spent elsewhere. But you might choose to back up your position with positive elements. So if I was really going to say, I think the Endangered Species Act is bad, or I think it's good, I need positive elements to back it up, like data. So maybe then I go into the positive elements in my normative paper. What are the estimates of costs of the Endangered Species Act? What are the success rates? Does it even work? So understand that if you're asked to do something normative, then you're asked for your opinion, and then that's okay. You might still want to use data to back up your opinion so that your opinion sounds more valid, but make sure that's what you've been asked to do, give your opinion. Now, consider the following statement. Longwood University is not making enrollment a priority. Longwood University is not making enrollment a priority. Well, do you agree this sounds like an opinion? And it's opinionated, obviously. It's a value judgment because we can't really test it. As expressed, it's a normative statement. Could I say the same thing in another way? Yes. So what if instead of saying Longwood University is not making enrollment a priority, what if I said data shows that Longwood's enrollment has fallen by 6% in the last year? This is just a fictional example. Well, now I have a statement that is indeed testable, right? And now I can use this type of data to defend my normative position that Longwood University is not making enrollment a priority. Do we agree this second statement is positive? So please understand the distinction between normative and positive. And when you're doing an assignment and you find yourself being normative, and sometimes I find myself writing in the normative in a form that I should be in the positive. So that might help you not just in my class, but in any of your classes. Let's think about how this connects to assignments for this particular class. As I said, I might ask you for an opinion then be in the normative. We probably want to use positive information to back up our points. And if you were going to use positive information to back up your points, what could you use? Well, you could use things from your field notebook, because you're going to be using a field notebook as we travel around Costa Rica, and you can recall that information. What about your own observations? Certainly you can talk about what you're seeing. Your own experiences, those would be positive pieces of information if you can speak to a concrete experience that you've had. And of course, what's been learned from your professors, from your local guides, from your hosts. You're going to be getting all kinds of good information, and this generally will be positive. Now, sometimes they might get into the normative, but when you're writing down information, they're telling you about regulations and strategies for protecting the environment. That's all positive. Now, you will have some assignments, especially your final culminating assignment in this class, where you might be asked for your opinion, but you have to back it up with information that is positive. Let's move on to talk about sources of data. I know you've heard about the idea of relying on primary sources. So what are primary sources? Primary sources provide first-hand information. First-hand information. So we're talking about data that's generated, or information that's generated from experiments. So maybe I'm a scientist, I run an experiment, I've generated primary data, right? I give a survey, I've generated this first-hand information. So we're talking about things that are first-hand data collection. Now, lots of peer-reviewed journal articles. This is the kinds of things that your professors are writing, and they have to publish them, and they're peer-reviewed in the sense that other people are going to read them, and they're highly critical, and you have to pass muster with the peers in your field that are experts in this area that are reading your paper. So lots of these peer-reviewed journal articles that your professors are publishing involve scientific studies, and that would be primary data. Those would be primary sources of information. Or they're using surveys that they've written, they've delivered, that would be primary data. So as an example, one of my favorite colleagues, Dr. Hank, has been working with crawfish in his lab at Longwood University. So he's doing the work studying the crawfish, he's generating primary data. I've generated my own primary data through surveys. So I've got big data sets through surveys that I've crafted and I've delivered and I've collected. And of course, then we have large databases. There are many places that researchers go to get information. For example, the U.S. Department of the Census would be an example of, this says U.S. Department of the Census would be an example of primary data. They collect data when they take the census, right? You've maybe had a census survey sent to your family, somebody fills it out, they turn it back in, and the Department of the Census collects this information, evaluates it, and characterizes our population in the United States based on this. That would be a primary source of data. But we also have secondary sources, and secondary sources can also be useful for us. They use data from other sources to do their own analysis. So read that again. If you are a secondary source, then you used data from other sources. So maybe I use Dr. Hank's information that he generated on crawfish, or I use somebody else's data, maybe the Census Bureau's data, and I do my own analysis using their data. That would be secondary. So for example, let's say there's a study by Smith in 2018, and that study does modeling using data from the Census Bureau. Now that study by Smith generates its own conclusions, but it does it using data from the Census Bureau. Or maybe there's a study by Brown in 2022 that used data that was published by an environmental organization. And Brown is taking that data, but doing their own analysis on that and generating potentially new conclusions. I collected data about high schools in Virginia, and that data created a huge model that I did a lot of statistical work from, but that data was available on the Department of Education website. So that would also be a secondary source because I didn't generate the data, I'm analyzing existing data. So when I use data to create my own economic models, my own statistical models, secondary. Then we have tertiary sources. And tertiary sources are summaries of other people's work. This might be Wikipedia or an encyclopedia. Now, we all agree that an encyclopedia versus Wikipedia are very different qualities of resources, right? And it might be at times appropriate that you go to some kind of encyclopedia. I know there are encyclopedias that are specific for disciplines, but generally they're not a good replacement for primary or secondary sources. So if you see in Wikipedia them referring to a data set, well, instead of using Wikipedia's take on that data, you should go to the primary or secondary source. So in summary, primary sources is the original data collected. Secondary sources is the study that uses the data collected by others to generate some new conclusions. And tertiary sources are summaries of those primary and secondary sources. So primary data sources are where we want to go to, if at all possible, but secondary sources also make big contributions, right? I can do a lot of great work using Department of Education data, for example. So we can read the analysis performed with primary data in those secondary sources. So generally we would say primary and secondary sources are your go-tos. We generally want to avoid tertiary sources. And I know your professors have told you over and over, Wikipedia is not an appropriate source. But it's possible that you find something interesting on Wikipedia, but then you need to go back to the primary or secondary source. So let me give you an example of this. This is a Wikipedia entry related to gross domestic product per capita across different nations. And you see here rankings of different countries and some dollar values showing their gross domestic product. All right. What you see here is that this Wikipedia page is summarizing 3 key sources of data. But this Wikipedia page would not be a good source to use, and I never would just assume that they had this correct. I mean, what if they've gotten it wrong? I need to go to the original source. So what are the primary sources? Well, we see 3 of them. The International Monetary Fund has collected data, and they're reporting it somewhere, and I can go find that. And then the World Bank data is being reported here, but I can go to the World Bank and get that data directly. And the Central Intelligence Agency also collects data. And so that offers me 3 primary sources where I can go to. So gang, you should never use Wikipedia as a source. But if you just want to get the lay of the land, going to Wikipedia might help you get kind of a sense of what's available. There are some valid Wikipedia pages. There are also some very bad ones, I'm sure. So never use them as your source, but use them potentially as a way to understand a little bit more and then take a deeper dive by going to the sources directly. And that's the best approach. I know you understand that. When we talk about getting information, as we've just described, science professors, scientists in the real world typically collect their own data. So I have a son who is studying to get a PhD in chemistry. He is in the lab every day doing his own research that is firsthand, trying to collect his own data. Economists and other social scientists often do the same. Not always, but a lot of us are involved in collecting data. For example, an economist might design and execute experiments. We do experiments similar to kind of what they do in psychology. We design them differently, but that would be primary data when I ask people to make a whole bunch of economic decisions in a laboratory setting. When we're doing this kind of thing, we're collecting our own primary data. So as I said, lab experiments like in psychology would be an example of this. As I've already given you an example of, some economists use their own surveys to collect primary data. And so I've done surveys where I've asked students about their attitudes about group work. That would be collecting primary data. But we can also sometimes use the data that are in the large databases, and we've already talked about one, right? The Census Bureau would be a large database. So when we talk about large databases, most of the time we might be talking about the ones that are maintained by state and government agencies or by nonprofit organizations. These are primary data sources. So we just looked at 3 of them on that Wikipedia page. So we could go to the CIA World Factbook, we could go to the World Bank and get data from them. Those are great databases where we can go collect information. In fact, the World Bank has all kinds of variables that they have acquired and they make them available. So primary sources for information generally are peer-reviewed journal articles and then these types of databases. Now, I'm not going to ask you to do a lot of reading of peer-reviewed journal articles. In economics, they would be highly technical, but I know in some of your other classes you might be asked to do a lit review. So some examples of primary databases. We have the EPA, and they do a national lake assessment that talks about the condition of lakes in the United States. That would be a primary data set. Then we have the IUCN Red List, which addresses endangered species. eBird gives you data on global bird species and their distribution in across the globe and their abundance measures. We've got poverty and equity data portals, which gives you all kinds of data on poverty by country. So these are generally kind of big searchable databases. But peer-reviewed journals, as we said, are where researchers publish their own original work in these types of journals, and they could be primary sources where they have their own data generated in the study. But remember, they could also be secondary sources where they do a new analysis, but it's based on somebody else's data. So if I were to give you examples in a quiz, you should be able to tell me when we're talking about a study, is it a primary data source generating their own data, or is it a secondary source where they're doing new analysis based on somebody else's data? So this information is critically reviewed by experts in the field, and they ultimately get published in journal articles, which are a key source of information. And you can access these kinds of articles through academic search engines. For example, sometimes when I'm trying to look for information that would be good for a kind of study I'm doing, I might start by going to Google Scholar, which is free, different from Google. If you've never used it, it's great. You can go to ResearchGate, where professors have and other academics have put information up, papers that they've written, and usually you can get them without any cost. You've got the Web of Science through the library. You've got ECON Lit through our library. There's just tons and tons of other search engines that are offered through the library. So let's say that I wanted to read articles about Costa Rica. Now, if I just put in Costa Rica, it's going to be a pretty broad search. I'm going to get all kinds of hits that are random. But what if I wanted to say Costa Rica's use of hydroelectric power? Now I'm narrowing down a little bit. I can go to the library and go to some of the more general search engines, and I'll get lots of different hits. I can restrict it to what years I want to look at. Maybe I only want really new stuff in the last couple of years. Maybe I only want things that are in refereed journal articles. Maybe I only want things that I can get the full text article. I don't want to have to go find it in some other place. So here's some idea of what these journal articles might be published in. These are our peer-reviewed journals, and it's just a handful of them, but they are a good source of information. All right, so let's talk about where to get good econ data, because you will be doing some stuff where you have to collect econ data. Well, the first source that I want to direct you to is the CIA World Factbook. It gives you country-specific data, and you can look up by a country. And I like this because once you look up the country, you can get all the information for that country. So when you put in Thailand or you put in Costa Rica, it's going to give you an overview of more than just the economy. They cover environment, education, type of government, and this is a primary source. So the CIA World Factbook is a great thing for you to know about because if you're doing anything related to a country, it's a great way to get the lay of the land for that country. So this is what it looks like, and here I've just kind of randomly pulled up Ecuador. So if you're interested in the country, you put in the country's name and it's going to give you an introduction, talk about geography, people and society, government, economy, energy, communication, transportation, military, and security. And it goes on a little bit further. Agencies and these kinds of banks, such as the following, also collect a lot of data that is publicly available. And they have staffs of economists who are doing a lot of work. So here are some other sources. So the CIA World Factbook we talked about, they also have lots of economists on their staff. But the World Bank is a great source. We've already looked at that in the Wikipedia page. International Monetary Fund, that was also one of the sources in the Wikipedia page. The Federal Reserve Bank has extensive information that's available for economic data. So these would probably be the places that I would start if I was looking for good economic data. Now, government agencies, both federal and state, have good data as well. They're generally more focused on domestic data, but for example, I can go to the U.S. Bureau of Labor Statistics, and I'm going to be able to get all kinds of things. You can imagine if I wanted data on unemployment, that sounds like a good place to go. We've got the U.S. Environmental Protection Agency. They also have lots of good data. U.S. Bureau of Economic Analysis. They're the ones that evaluate if we're in a recession or not. So they also report great data. The economic report of the president. Of course, these are not going to be international. So if you were looking for things on Costa Rica, these would not be places to go. But if you wanted to compare Costa Rica to the United States, well, this might be where you need to go to get information on variables of interest here at home. Now, where do you go to get the good science data? Because if we're studying sustainability, obviously we're looking at both themes. So at home here, we've got the Environmental Protection Agency, and they conduct national studies to collect baseline environmental data. So we've already said that they do this national lake assessment and create this database. And that's a statistical survey of the conditions of lakes and ponds and reservoirs, but of course for domestic water resources. And that data is available to anyone who wants to get it. So if you went to the EPA and you looked up this assessment, it would basically look like this. So I just pulled it. This was a number of years ago, but an example. Now, obviously they're using graphs to illustrate a lot of their data, but there's also going to be indicators that you can look up as well in more of a chart form. Nonprofit agencies also collect a lot of primary data on the environment. For example, the Worldwide Fund for Nature, or the Sierra Club, or Greenpeace, or the Natural Resource Defense Council, the World Wildlife Fund. These are great nonprofit agencies working on environmental protection. They would also be a good source of data if I was trying to get things related to science, especially with respect to the environment. All right, so we've talked about data sources, and obviously I don't expect you to use every one of those kinds of things, but I want you to be aware of the type of sources that we would expect you to use if you are asked to go in search of some data. Let's move on to talk about bias in data, because this is also a very important point. It's important that we evaluate the data or information that we're using and that we consider the source. So guys, what we're saying here is just don't grab any data. Think about where you're getting it from and evaluate it, because we want to avoid bias in our own data. We definitely don't want to paint a biased picture. That means we want the data to be representative. Right? We want to tell a representative story. In other words, we don't want to design our data collection just to support our own hypothesis, right? We don't want to be accused of hand picking, right? Picking and choosing, cherry picking just the data that supports our point of view. That would not be very good scholarly work, right? We need to ask if our data paints an unfair picture. So when working with data, we need good data, but we also need to think about the data itself to make sure that there's no bias. For example, we might be introducing selection bias. So let's make sure we understand what selection bias is. Selection bias is where data is selected from a subjective as opposed to objective perspective. All right, so what do I mean by that? Well, maybe I use a sample of data that doesn't reflect the population as a whole. Well, that would be a bit misleading, right? Maybe the data is selected non-randomly, right? You've heard that we want to kind of randomly select data. So imagine we're interviewing people. We probably want to kind of be randomly selecting people to interview as opposed to picking and choosing just to confirm our own point of view, right? Because if we do that, then it would be manipulation. But selection bias can result from simply not being careful. So if I pick and choose, I'm manipulating the situation. Clearly, I'm leading towards selection bias. I'm causing the selection bias. But what I'm trying to say is that selection bias can result simply just by being careless because you're not thinking critically about what you're doing. Let me give you an example to help illustrate this. Let's say I survey people to find out their attitudes about the current president of Costa Rica. Let's say I'm in Costa Rica and I'm asking people, hey, what do you think about the current president? Now, what I want to do is try to get a random sample of people, right? So that it reflects the population. But what if I survey mostly people in the National Liberation Party? So that would be just one of their political parties. That would be like being in the United States and focusing mainly on just Republicans or mainly just on Democrats, right? So if I survey people that are mostly in the National Liberation Party, that would be like me not randomly drawing a sample from the US, but somehow getting a sample from people who are mainly Republicans. Well, I'm going to get a very different point of view from them than if it's mainly Democrats versus if it's mixed, right? We understand that this is going to skew the information that we obtain, right? So if it skews the information we obtain because we're not collecting data in a representative way, we have introduced selection bias, right? Is this making sense? Hopefully it is. Let's look at a second example. Let's say that I report data on deforestation rates, and I'm trying to emphasize, look, deforestation is a concern. But to do that, I select the years with the historically highest rates, right? Does that make sense? So maybe I'm really trying to hit home this point. Look, deforestation is bad. We need to focus more on deforestation in Costa Rica. But then I try to get normative. I get away from the normative by getting positive, and I want to use some data, but I select the data with the most historically high rates of deforestation because I'm trying to drive home my point, right? But I don't reveal this. Now, if I say, look, in these 3 years, we saw the most extreme rates of deforestation. If I'm transparent about it, then that's okay. But what if I don't reveal this and I just say, look, at some deforestation rates. Look how high they are, right? If I do that, then what I'm doing is I'm going for the highest shock value. And what I'm doing is painting a slightly misleading picture, right? So when you're reporting data, you want to report it fairly. And sometimes that means reporting a trend over a longer period of time so we can kind of see a before and after. We can get a general sense of what maybe the last decades look like. Do not just pick data that goes for shock value, right? It needs to be representative. So I'm guessing that makes sense to you. All right, let's move on to an important topic, correlation versus causation. And this is one place in economics, and other fields that people really make mistakes. It's a big area of confusion. So correlation versus causation, and we need to be very clear that these are not the same thing. And because they're not the same thing, we have to be careful about the conclusions that we make from data. Let's first explain these ideas. When variables move together, either positively or negatively, we say there is correlation, right? So if variable x and variable y move together in some way, then we say there's a correlation. But here's what we have to be careful of. It does not mean that one variable caused the other to change, right? So from this correlation, we need to be careful. We can't say, oh, because they are correlated, they move together, one causes the other. No, can't do that. We need to be careful to determine if there's just a correlation or if there really is a causal story. Now, it's possible that X does cause Y, but we can't tell that simply from a correlation. A strong correlation could just be due to chance, and we see examples where two things are correlated and it's just due to chance. There's not really any relationship there, and we call that a spurious correlation. So when we think we might have a spurious correlation, we're just going to have to apply some logic. And there are lots of famous examples of spurious correlation. And again, spurious correlation where there's a strong correlation that's just due to chance. So I could show you a ton of examples, but I'm only going to show you one famous example of spurious correlation. All right. So here we have divorce rates in Maine, that's graphed in red, and per capita consumption of margarine in black. Guys, look at those trends. They are highly correlated, right? Highly correlated. Is there a causal story though? Guys, do we think that consumption of margarine leads to higher divorce? Or maybe it could be the other way. Maybe higher divorce rates, people are all bummed, so they start eating a lot of margarine. We agree that neither of those stories make any sense. So we would say, look, these seem to be correlated, but it's probably just by chance. It's not clear that there's really any relationship there, and there's also not a causal story, right? We want to be careful that, okay, technically these things are correlated. If I estimated a correlation statistic, it's going to be very, very high. But is that a meaningful correlation? Would I want to report this and say, guys, wow, the divorce rate in Maine is highly correlated with the consumption of margarine? People are going to be like, that's spurious, right? And clearly no causal story. You get the idea. So when one variable is thought to have caused movement in the other, then we call that causation, right? When one causes the other to move. When they're related, they move in the same or opposite direction, that's correlation. But when one variable is thought to have caused movement in the other, then we call that causation. So the variables would be correlated, and then we wouldn't call this a spurious correlation. If there's a causation story, then clearly we have a correlation and it's not spurious. And it's not spurious because one thing causes the other, right? So correlation versus causation. Now, when we talk about causation, we could have different instances. Maybe variable A increases and it makes variable B increase as well. Or variable A decreases and makes variable B decrease, or variable A could increase and make B decrease, variable A could decrease and make B increase. You get the idea. Those are all four possible combinations, right? But those would be causal stories because I'm saying A causes B to increase. Causation. So here's an example. We've seen increased deforestation in South America. And we also see increased water pollution. So we have two variables that, if I plotted them, do move in the same direction. Both are increasing. So we would want to ask the question, is this just a correlation? That there's something else going on that causes increased deforestation at the same time as increased water pollution? Or is this a causal story? Well, it would depend a lot on the specific situation, but we could certainly think through a causal story, right? When we have increased deforestation, we have more runoff, more erosion. That increases water pollution, especially if deforestation is being replaced with farms and we have chemical runoff from things like pesticide. That creates more water pollution. So again, just be careful when you talk about correlation versus causation. Before you say something is causal, we would really need to have investigated that further. All right, so let's wrap this up. As we proceed in this class, you need to be thoughtful about the use of data, rely on primary sources when looking for data, or secondary sources. Remember those things that do their own analysis from others' data. Be careful to recognize normative versus positive. When you're asked for your opinion, if you have an assignment like that, then normative is appropriate. But other times you should be focusing on positive. Either way, remember that normative ideas can still be justified with positive information like data. And economists clearly like data. When you're making connections, you should think about correlation and causation. Keep in mind that correlation is easy to prove or disprove because it's a statistical calculation, but we do want to think about spurious correlation because, as I said, if I looked at margarine consumption and divorce rates and I calculated the statistic for correlation, it would be very, very high, but we would say that's spurious. It's really by chance. There's no connection at all, no reason they would move together that we can explain. Causation, however, is much more difficult to establish. Keep in mind that correlation doesn't prove causation. Thanks for listening, guys. If anything's unclear, email me with your questions. Otherwise, have a fantastic day.